intersection of three planes. So let's see and visualize how our solutions reflect to the planes themselves. So the question here is, how will you interpret the solution to the following systems geometrically? So we are given here the three matrix solutions. So basically when you have three equations for the plane and we solve them, then you get these kinds of solutions. So it basically says when you reduce your equations, then what you get is this, and from here you can see whether solution exists or it does not exist. And if it exists, or even if it doesn't exist, what is the situation? Now in this particular case, A, what you notice is that 0, 0, 0 equals to 2, which is false. 0 cannot be equal to 2, so this system is inconsistent, right? Now here again you get 0, 0, 0 equals to 3, so this system is also inconsistent. In the next one, 0, 0, 0 equals to 0, it is consistent system. Right? 0 is equals to 0 for all the values. Now here when we say 0 equals to 0, that means we have one parameter. Now the next row is not 0 equals to 0. So now we have one parameter, so the solution involves one parameter. So that means the planes, they intersect in the line. So the intersection is a line. So line is the solution here. So line has one parameter, so the intersection of all the three planes is in a line. So that is what we see. Now let's get back to the very first one now. So in the very first one, what you observe is that, well, this is not an intersection. So in this case, what really happens is the two planes, and you get all the zeros in a line. That means two planes are parallel. So two planes are parallel, and the third one is kind of in between them, right? So that is how you get this situation. Let me just draw and show you how it should be looking like. So we have one plane like this, and the second plane is kind of, let me just make a wider one here. Let us say, so the second plane is kind of here. Then the third plane actually intersects these two, but at a different level, right? So, or both individually, kind of, do you see that? So it intersects one in one line, the other one in the other line. So that is how the third plane is there. So the two planes are parallel. We get these two planes parallel since the last row is 0, right? So all three zeros there indicate that we have two planes which are parallel, and but since the system is inconsistent, there is no common line of intersection, right? So that is how it is. Now in this particular case, what we have is that both the statements are false. 0 cannot be equal to 3 and 0 cannot be equal to 2. But we see that there are two parallel, rather three parallel planes, right? This is two parallel planes, one row of zeros. Two rows of zeros means 2 plus 1. Three parallel planes, right? So we have three parallel planes here. So we can just draw three planes parallel to one another, right? So this is how we can draw them. So we have one plane here, the other one kind of, right? So there, and then the third plane. So we can draw three planes parallel to one another, and that represents the given situation. So that is how system B is. We have three parallel planes, right? Now C is consistent, and since we have 0 equals to 0, which represents a line. Now in this particular case, what normally we'll have to see the normals of the two. So if you check for the normals, and if you find that two of them have parallel normals, then the plane could be parallel. So there are two scenarios in this, right? There are actually two scenarios in this. But most probably in this case, all the three are intersecting in one line. So that is absolutely clear from here, right? But the row is totally like 0, 0, 0. That means two can have same normal also. So there are two possible solutions here. So one is that we have two planes here, which is kind of like this. And the third one crosses them. and so you get a line, right? So you get a line here. So that is how you get a line, right? And I should have made that dotted, but that's okay, right? So that is how the situation is. Or it could either be that there are three planes which cross one another, like I'm showing here. Right, from the same point. So we have three planes here. We can just cross this like this. So three planes intersect in a line. So that is, there are actually two possibilities, but once we know the normals, or rather the equation, then we can make out which one is the right solution. But in either case, in this particular case, what we will observe is that n1 scalar triple product will be 0, dot n2 cross n3 will be equal to 0, right? And in this case, what you'll observe is that n1 may be two planes normals will be scalar multiples. So which ones? These two planes, for example, n1 equals to k times n2. So that is a possibility. So either one of those things could be possible. So we are not very sure about it at this stage, but a final solution like this represents either of these two cases. Okay, thank you.